With similar figures, they are figures that have the same shape but not necessarily the same size as another shape. For example, if I've got a circle, whether it's tiny or big, they're always going to be similar. Same with a square. Regardless of the size, they are always going to be similar. All the angles inside a square are exactly the same as inside another one. The symbol for similarity is 3 parallel lines vertical. If I have something like a right-angled triangle, and if I have sides of 3, 4 and 5 units, and then I draw another one, another right-angled triangle, and if that had sides 6, 8 and 10, those two triangles are similar because that side there is twice as big, that side is twice as big, and that side is twice as big. So all the sides are in the same ratio. And that's one of the tests for similar figures. If all the sides are in proportion or in the same ratio, then the triangles are similar. If I have another two triangles, say if this angle in this triangle was exactly the same as the angle in that triangle, and this one here was exactly the same as that one there, and this angle here was exactly the same as that angle there, then these two triangles are also similar because their angles match. So the angles in one triangle are exactly the same as the angles in another triangle. With these next two triangles, because I've got one triangle with sides of 6 and 15, and this included angle, and this triangle's got sides of 2 and 5, and this angle is the same as the other angle because they've both got the same marking. Now, this side is 3 times bigger, and that side is also 3 times bigger. So those sides are in proportion. So we've got two sides in the same ratio, and we've got an included angle because it's included between those two sides, and an included angle is the same. So these triangles are also similar because they've got two sides in the same ratio and an included angle is equal. And lastly, with a right-angled triangle, if we've got two right-angled triangles and we're trying to see if they're similar, they've both got the right angle, so that's one thing in common. This side being the hypotenuse, that hypotenuse is half the other one, or if we go the other way, it's double. And then that one to there is also half. So the sides are in the same ratio. We've got hypotenuse, and we've got another side and a right angle. So if we've got a right angle and a hypotenuse and a side is in the same ratio, then the triangles are similar as well. Now if I call this triangle ABC and this triangle DEF, if I want to say that triangle ABC is similar to triangle the other one, now I should go in the same order. If I've started at A, gone to the right angle and then round to C, I should do the same in the other. So I'm starting at F, go down to the right angle and around to D. So that is triangle FED. By doing it that way, we're saying the side AB corresponds with the side FE, or the angle at B corresponds with the angle at E. So that shows which parts are similar to the other one. With these two triangles, if these two triangles are similar, which they are because they've got these two matching angles, that one and this angle matches that one, which then obviously means the third one matches, so we know they're similar. Because they're similar, we can find out the value of x. We put x over the side that matches the x in the other triangle, which happens to be 20. Then we go back to this triangle, the other side, which is 25, and we put it over the side that matches it on the other triangle, which is 30. Then it's an equation, so we want to get rid of the 20, so we times by 20. Whatever we do to one side, we do to the other. then the 20s cancel, and we're left with x equals 25 times 20 over 30. I'm going to cross those out. 25 times 2 is 50. So the value of x is 50 over 3. We can change that if you like. 3 into 5 goes once, remainder 2. 3 into 20 goes 6, remainder 2. So the value of x is 16 2/3. And you can use that idea to find out any side on an unknown triangle if the triangles are similar. A couple of things to think about when we're doing similar triangles. There's two triangles here, but if we're trying to figure out if they're similar or not, because these lines are parallel, you should remember some information about parallel lines. The fact that this angle here is going to equal that angle there because they are alternate angles. This one here is going to be equal to that one because they're alternate angles as well, and I should say on parallel lines, because if the lines aren't parallel, they aren't equal. And this angle here is the same as this angle here because they are vertically opposite each other. Sometimes we have to look at that when we've got similar triangles. Another one is something like this. Okay, there are actually two triangles there. The little one, which is there, and the big one that's there. So if we were trying to compare those two, it might be easier to draw the little red one and then draw the big green one and then think about the sides from there. So you might need to practice doing a few questions with similarity to make sure you're okay with that.